All right, folks, welcome to another episode of Beyond the Noise, Signals, Stories, and Spicy Takes, the show where we dig into the stories of the people shaping the future of app-based computing with a special focus on mobile. I'm your host, Matt Klein, co-founder and CTO of Bitdrift, as well as the founder of Envoy Proxy. Each episode, we'll talk with engineers, founders, and technical leaders who've transformed the way their companies build and understand what's happening inside their systems. We'll dig into the challenges, the breakthroughs, the lessons learned, and we'll wrap it all up with their hottest takes. So let's dive in. Today, we have Jay Gengelbach, who is a software engineer and engineering leader. He spent 18 years at Alphabet, growing from an entry-level software engineer to a principal engineer through a career that spanned Google's observability infrastructure, payments processing, and search teams, and then Alphabet's life sciences startup, Verily. In 2025, he joined Vercel, where he continues working on web-scale infrastructure challenges. Welcome, Jay. Thank you for joining us.
Yeah, it's great to be here.
Yeah, I just want to let people out there know I do not know Jay at all. And how this came about is Jay posted an absolutely awesome bug story on LinkedIn that we will dive into later. It just got me thinking. I was like, wow, that is an amazing bug. And I love amazing bugs. But before we go there, how we typically start is just to learn a little more about you. So could you just give us a brief intro in terms of how you got into computing in the first place and how you got to Google and some of the exciting things that you worked on there, and then how you got to Vercel currently? That would be fantastic.
Man, so yeah, I have been programming computers since about fifth grade. I, weirdly enough, got exposed to computer programming at my piano teacher's office. They had the old, like, blue screen Commodore 64 computers
Wow.
in their waiting room with some music-related software that you could play with. But in that era, the Apple II and the Commodore 64, if you booted it up and just started typing at the prompt, it supported BASIC. And so someone like turned it on without a floppy disk in. That's when the floppies were actually floppy. And he just like booted it up and wrote just a little choose your own adventure, just like stupid little like text-based BASIC thing.
How did you know,
just,
though? Like, how did you know what to type? I mean, was there like a basic manual sitting next to it?
I mean, so yeah, one of the other students just knew what to do. He did it, and I just kind of like looked over his shoulder, asked him what he was doing, and learned like, if and go to and print or something like that. I learned like the very, very basics of BASIC. And what I really learned was a search term. And of course, it didn't have Google to type that into, but like from my school library or things like that, was able to pick up a few books on BASIC and just start tinkering around with stupid things. Through a lot of middle school, I would do a bunch of, I just would call them screensavers. I'd just like write some rules to animate like a circle around the screen. Maybe it would change colors when it hit the wall and like bounced off the wall, or just like, try painting random colors on the screen. But basically just got into, I thought I wanted to make video games. That's kind of where it all started, was the dream of making video games, but loved computer programming, and so was pretty into it from an early age. I actually found one year I would write like pencil and paper, like computer programs in my notebooks at school, and then like go home and type them in. And years later, I found one of these and like typed it in, and I was a little surprised. I went home, typed it into a BASIC interpreter, and it just ran flawlessly the first time around. Like, that's always a surprise, I think, for any seasoned engineers when the code works the first time through. And I was like, I did this as like a sixth grader, and it worked. Although
I was going to say, I haven't had this memory in a long time since you just talked about it, but in high school, I also, I think in some computer classes, I do remember writing computer programs by hand, like you're saying. And just like in the current day and age, where you're sitting in an editor and, these days you're having some AI tool write half of it for you. It's just pretty crazy to think about how much has changed in that period of time.
Yeah, honestly, you adapt to the tool that you have, though. Because I was doing it by paper, I spent a lot more time thinking through everything and like making sure it was all correct. because the feedback loop was so slow and so painful. Like
Yeah.
to write 600 lines of code before you like run any of it and test it, you behave differently. I think people back in the punch card days behaved differently, and like they were able to get by with it. Whereas, one of the jokes I've made in the AI age is like, now I know languages that I also don't know. Like I've written production code in these languages that, like, if you asked me to write like a for loop on a whiteboard, like I probably wouldn't get it right. But I'm shipping code in production because like I offload knowing the syntax to the AI, and I just bring the product management to the arena. So yeah, I've been programming for a long time. I went to school for computer science, and like I knew I wanted to be a computer programmer, a decade before that. And really so I went to Purdue University, and I remember just going to the orientation presentation that they had on campus for prospective students. And really the only question in my mind was, what is the name of the major that I want? Like I knew I wanted it to be computer programming. And like they explained the difference between like electrical engineering, computer science. And I was like, computer science, that's the one. Yeah. Never looked back. That's been my niche forever.
Yeah. Fantastic. And then it seems like you had a very long career when you were at Google. Is that the first place that you worked out of school?
I had a couple of internships before my senior year. Had an internship at Microsoft, and actually fully expected to go back to Microsoft after graduation, but they wanted me to like sign that contract before I left the internship, and I was like, I expect to come back, but I want to keep my options open, and I'm glad I did. That was the first year Google came to Purdue's campus and recruited, and they just sold themselves in a way that seemed a lot more exciting to me. I mean, it's weird to say now, like that was the thing where I was like, I don't know if this Google thing is going to catch on, but maybe it'll be it may never be a Microsoft, but it'll be a fun ride.
Yeah. It's also funny how things come and go and ebb and flow. I mean, I feel like in that era, Microsoft was decidedly not cool and Google was cool. But now I don't know who's cooler. Is it Microsoft or Google? It's actually really hard to say. But it sounds like you worked on a lot of really interesting things while you were at Google. Before we, completely nerd out and talk about that bug and then go from there, are there any, particular things there that you would like to highlight?
I have a lot of good war stories through the years from all the teams that I've been on. I like to geek out with them. Google's kind of notoriously tight-lipped about a lot of their stuff, and so sometimes I was like worried about what I could talk about, but I think I've gotten enough distance from some of these things that the one that we're going to talk about today, we like made a defensive publication about it. So like it's literally public on the internet.
Yeah.
A lot of the details there. So I'll add a little color to it. But yeah, I love telling these stories. I mean, yeah, like a million QPS is like a medium-sized service at Google.
Yeah,
and
sure.
So you just run into these absurd sorts of situations, working at that scale where things that seem, astronomically small odds just happen to crop up. Oh man, I remember my first project, I ran into a deadlock bug, which, happens from time to time, but it was a 3-thread deadlock bug where it was not just like two things that just like acquired 2 locks in different orders. It was like, it was the classic, like, dining philosophers with the chopsticks. It was like, it was
right.
n equals 3, and like you just needed all 3 threads to hit the right, the right place at the right time to trigger this. And it was like, what are the chances? Well, we do this operation, a couple 100 million times a day. So the chances are higher than you think.
How did you find the bug? Were you able to get a stack trace? I mean, so it was
great thing about deadlocks
once you got the stack trace for it.
As soon as it dumps core, like the threads tell you exactly where they are and what they're waiting on, and it becomes very clear.
Well, you also, I mean, you probably started at Google, I mean, really right when mobile started to blow up, right? So, I mean, you were there basically.
Before then, I was there in 2006. So yeah, pre-iPhone, pre-Android. Like I remember when they like acquired Android, when they gave us all Android phones for Christmas, because they just wanted developers to have these and to start thinking about them.
Yeah. It's more what's interesting is you were there really during the time period in which web is the thing, right? It's like web is where everyone goes. And you were there during the transition from where, these days, I don't know what the percentage breakdown is, but for a lot of companies, it's like 90% mobile and 10% web, right? It's kind of interesting that you were there during that transition. And I think the bug, that we're going to talk about is a mobile specific bug, but I'm sure that, you saw a lot like during that period of change, right? Where like the company's focus is web, 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 and then it starts to switch more towards mobile, I'm sure.
Yeah, well, and having done Microsoft right beforehand, also sort of experienced that transition from like local apps to web. The team that I interned with at Microsoft was core file services. So it's like check disk and format and things like this. And the like check disk sometimes runs like as part of the boot loop, like before the rest of the operating system is there. And so they wanted me to do some like caching in there. And I was like, okay, can I use like a red black tree? Can I use this data structure? And they're like, no, you can't use any of the STL. None of that exists. Like, we don't even know, like we've got like 32 megabytes of memory at this point, and that's all we know that we have until we run check disk. And every memory allocation you do, you have to be like, did the memory get allocated? If not, how do I fail gracefully? And I remember just in my like noogler training at Google, someone was like, yeah, should you be checking your allocations? And they were like, no, God, no. Like, if you can't get memory, just crash. There are 100 other servers doing the same thing. And if one of them dies, oh well. And if they all start crash looping, we'll look into it. But yeah, it was really liberating from this environment where like I can't use any standard libraries and like memory is undependable and like you don't know if you have it, to an environment where you're writing servers on the cloud, you control the computer that it runs on, you know what operating system it's running on, like down to the kernel version, and you could iterate so much faster at Google under that control. And actually the weird thing is when we moved to mobile, there are a lot of things that got more interesting and more powerful, but it like throws a lot of that back out the window, where it's like,
for sure.
When I worked on a mobile app team, it was like, oh, now we have clients running like Android versions from 6 years ago, and we need to worry about getting request. Like every time we release a new version of the app, we're going to be receiving that query forever, and we need to be ready to field that query from those old clients like for the rest of time.
And it's not just the old clients, it's that even for quick updates, even if you get a 90% uptake within a certain amount of time, it's still going to take you 3, 4, 5 weeks, like just to get that uptake. So I think, that was eye-opening for me as well, because I also did my career start back at Microsoft. And, I wouldn't be the software engineer that I am today without that type of foundational experience for sure. But then when I started to move, as you did, more into the web scale systems, it is really eye-opening how quickly you can break things, but also fix them. But in the mobile world, the code really does effectively live forever. So you definitely start thinking a little more about how all this stuff works. Anyway, why don't we dive into the bug that I originally saw, and then we can go from there. So I would just assume that the folks that are listening don't have any clue what we're talking about. So why don't you set the background, and then we can chat about it more.
Yeah, so the app I was working on at the time, we called it Google Now. It went through a couple different public names, Google Now, the feed, Discover. But I think if you open like Chrome on mobile these days, you see a bunch of like stories and things you can scroll through.
Yeah, for sure.
Those, like cards. Yeah. That is basically the app we were talking about. And it went through various iterations of being like assistive, where like you could connect your emails, and like if you got a package tracking link in your email somewhere, it would just like track the package for you and be like, hey, this has arrived, and things like that. And so sort of like use intelligence based on your location history and your email history to just give you things that might be useful to you. These days, it's basically evolved into here's some news to read for various reasons. But yeah, it was very like mobile first sort of application for trying to, it was called Google Now. The idea was like, what if we gave you search results before you even asked for them? Like, can we think about what you might be interested in and surface it to you, and try to determine your interests in various ways, and just like give you stories that are interesting to read. And so to have that be a fast on load experience, When you open it, it does background requests. And so in the background, it says, okay, if they open the app in the next 30 minutes, what should I show them? And so you'd make a request, we cache that so that you get content instantaneously when you open the app. And across the entire Google install base, this was basically like built into Android or built into the Google Search app, which are installed on like 1 billion plus devices. So if we're having that many devices making background requests, the system was somewhere north of 100,000 queries per second. Even at Google, that's a big number. There's not a lot of things that do that, or like some of the things that are much higher than that are like very simple requests, and like we had a heavy stateful request at 100,000 queries per second. And so somewhere along the way, the SRE team wanted to work on improving reliability there. So we want that query to succeed. I think we were pushing from like 2 nines to 3 nines. Maybe we were pushing towards 4 nines, something like that. But we wanted 99.9% of these requests to succeed in less than 1,000 milliseconds or something like that. So obviously, when you're doing that, you have certain like incidents that kind of push that number down, but then you also just have your like background churn rate, like your error rate, where things time out for one reason or another some percentage of the time. And so we were looking at just our background error burn rate, where like not really incident driven, but just things that happened spontaneously all the time. And our SREs like zoomed way in on the graph, and they saw we have a big spike in errors at the top of the hour every hour. Why? So we just started digging into that, and this might be a fairly normal thing in a normal company. Things that happen at the top of the hour are kind of unheard of at Google, because when you're dealing with billions of devices, like you never tell the device to do something at the top of the hour.
Yeah,
like
for sure.
Like even an entry level Google engineer, like quickly, like if they see that in a code review, they're like, nope, like never pick the time. The time is always random. So you always have to randomize your callback time for something like that, because you have to spread the billion requests that you're going to get over an hour, like across the entire hour. So it's rare to have these time aligned events. And so one of the first things that we looked into was like, did we screw that up somewhere? And no, we didn't. So this is kind of where the things start, kind of where I come in, and I start like zooming in on the graphs to see what the heck is going on, what's happening at the top of the hour. And
sorry, for this, you're looking at server side graphs, obviously, right? Like you're looking at the incoming request rate. So you don't yet know, or do you know at this point, what is the client side success rate? Because obviously those could be different, right? I mean, you could have tons of requests that are going out the client that themselves are not succeeding for any number of reasons. So I'm just trying to set the stage here.
Yeah, the SLO we were worried about was our server side SLO. And we did have some back channel reporting. So like for things like latency, we can measure it from the server side. So like from where we got the request, how long did it take? And that's usually what we base the SLO on, because we don't control how fast your Wi-Fi is. But we did also have metrics on the client side of like what's the client's view of latency and things like that. So as we zoom in, what we see is at the top of the hour, there's just a big momentary spike at like the first second of every hour. There's a big spike in load, like 15% more requests, very briefly. We also noticed at like 30 minutes past the hour, 15 minutes, 45 minutes, increments of 10, 10, 20, 30, 40, like all the round numbers have a spike. The top of the hour is the biggest. Midpoint is the second biggest. But it's like if you pick every number that you can divide it by, like you see all of them show up at lower rates. So we start looking into like why would that be happening? Actually one early theory. So we had a couple different. So we built this thing on the client we called request schedules, which was we sent a bunch of conditions down to the client and said basically like call us back if any of these things is true. And it's things like, if you hit this particular timestamp, that's the original version, the OG one that was in the app forever. But then we started adding things like, as soon as you open the app, let's just send a request and refresh the data for you. And then we'll figure out on the client how to like slide the new data in without you seeing it blink.
Yeah, and sorry for this mechanism, had you already had that in the app, or did you build this to debug this issue, basically?
So those request schedules were built over my tenure on the team. And so like we proposed them, we built them. And so one of our thoughts is like, we screwed this up. We built this wrong. We could also do things like geofences. Like when you get home, when you get to work, like we'll do a refresh. And so one theory was, we had this app open request and we're like, what if for some reason people open their app right at the top of the hour? Or they turn their screen on at the top of the hour. Like these are some of the events that sometimes result in a request. One of the great things about Google is you have amazing telemetry. Like they have this very detailed log record on every request that gives you all that information. And so we were logging, why did we make the request? What was the last schedule we sent to that client? Things like that. And
Right, but that's server side or that's client side telemetry, because that's where just I'm obviously coming from a mobile observability company, and it's this dichotomy between what you have on the server and what you have on the client, and then you have to line them up. It's actually really confusing. So that's why I'm asking these questions. Like I'm trying to understand for some of the debugging that you're doing. Are you looking at the server side, or are you looking at independently reported client-side telemetry?
So the client, obviously includes a bunch of stuff in its request, user agent, Android version,
Right.
IP
Okay.
address, all that stuff. So it sends up a lot of that stuff. And then on the server side, we log what the client sent us and also what we sent back to the client.
Got it. Okay.
So that was the main log source that I was using. We did have some other detailed client-side telemetry that we used in various places. I didn't end up digging very deep into that.
Got it.
I
Okay.
do recall actually one of the really tricky things in the middle of all of this. There was a big push from Android that's like battery life on Android is not as good as battery life on iOS. We want to fix that. And so they started saying like every new feature we want to push out, we need to run an experiment and measure battery life impact. And boy, is measuring battery life impact of a feature flag a difficult thing to do. And so yeah, like I didn't build that telemetry, but like they had the instrumentation that you could basically correlate total battery drain on on the thing with like the feature flags that you have turned on for a particular user. So yeah, so I'm using mostly the server side logs. As I dig into it, speaking of like the server side versus the client side, one of the things that I discovered is this big surge in requests. The load spike lasts about 3 seconds or so, but it all comes from clients who they believe the timestamp when they sent the request was exactly the top of the hour. So obviously, because of the network, it takes a little while. Like the server side timestamp,
Sure. Yep.
may not be the same for two reasons. One of which is just network lag. It takes a while for your packet to make it to our servers, and two is actually sometimes the client timestamp is newer than the server timestamp because your client has a bad clock. If you've read some of the Google papers on like Spanner, where we have like literally atomic clocks in data centers to be really sure that we know exactly what time it is. Clients don't have that. Most mobile phones do not have an atomic clock embedded. And if you care about high precision timestamps, like clock skew is a thing that you will know. And if you want a fun interview question sometimes, figure out how to synchronize the clocks of two devices that are separated by a network. It's not an easy problem. But yeah, so this spike in requests was coming. The clients all believed they were sending this request at the top of the hour. And we dug back into it and asked, and so the client says why it's sending the request, and they're sending the request because they believed it was time to send the request. Not because of one of the other conditions that we put into the request schedule. So they said it was time. But what we said is like, I told you to call back at 1:48 p.m. and instead you called 12 minutes later. You called at exactly 2 o'clock. So there were a large number of clients that we told them to call back. So like we did correctly tell them, call back at a random time, and they instead waited for the next round number after the point where we told them to call back. And that's when the request hit. And so we got this big spike in load from, it turned out to be a smallish number of clients. It was hard to craft the SQL query to figure out which clients were doing this. Because obviously when you randomize, clients across 3,600 seconds in the hour, some of them hit hit 0 naturally.
Yeah, of course.
Not everyone that sends a a request at the top of the hour is doing it maliciously or because of a bug. Some of them are just doing it because they won the lottery.
But were you logging when the client thought they were supposed to be sending the request, like either the client timestamp or the schedule time, and then I guess you could compare that against the receive time to see how far apart they were. I'm
yes,
trying to
I think part of why the SQL query was hard is because what we logged was what the server told them to do the last time they talked to the server, and I had to join that log record with the next one they sent.
Got it. Okay, makes
where
sense.
They said,
yep. Right,
"I'm calling back because I think it's time."
Yes. Yep. Okay.
And so yeah, there was some gnarly like log SQL to put all this together. But the story that takes shape is there are certain client IDs that have a strong preference for sending their requests at the top of the hour. And so like I did this aggregation of like what percentage of the time do you send your requests at the top of the hour? Because like if you won the lottery once, that makes sense. If you win the lottery 8 times a day, something's up. And so I was able to like identify some number of like client IDs that send traffic at weird boundaries and not at the time that we told them to. And so then I'm like, okay, I know the client IDs. Now, what do these have in common? What can I figure out about what they're doing? So, I looked by, IP addresses. Actually, some of these clients, of course, your IP address on a mobile device changes throughout the day. So, like, regionality didn't seem to do it too much. I think it was like maybe slightly more pronounced in India or something like that, but like not nearly a smoking gun. Android version, no. App version, no. So I was like, okay, is it, do they have a buggy client? Was 3 versions back a bad client that did this? No. The first clue that I got was sorting by Android manufacturer or like device, like the OEM, the manufacturer of the device. And of course, at the top of the list, you've got like Samsung and a few things like that. So, you've got the big ones. But of course, Android being open source, like there's a ton of Android manufacturers out there. And so there are like some of these small manufacturers that I had never heard of, but like there's one of them where it's like 80% of its users are bad clients.
Starting to smell like a hardware thing.
Oh yeah. So
right.
that's an interesting clue. They are not all of them, so that they don't have all the bad clients, and not all of their clients are bad, but significantly overrepresented versus the base install rate of this OEM. So anyway, in pulling on that thread, the other one that was really hard to do, so despite the fact that we have a lot of these logs, actually Google really locks down a lot of the like personalization logs. So one of the other theories I wanted to test was what apps do you have installed? And like Google has that because Play Store is one of the things that Google has. It's not my team. My team is not Play Store. And so like it took me a while to like apply for access to Play Store logs, but I was like, I want to know what APKs are on these particular clients. And actually my recollection is I didn't actually get anything out of that. that didn't turn up what I thought it did.
Yeah,
right. But what we traced this to in the end was battery saver apps. That these manufacturers, so that this particular manufacturer shipped with an app to save your battery life, and that app functioned by turning off Wi-Fi. And basically saying like background internet requests are only allowed from at scheduled times. Like we will give you like 5 seconds of internet connectivity an hour or something like that. And we will otherwise.
But you also said that you did see the issue on like Samsung devices as well. So was every manufacturer doing this in some form, or was that a red herring and like it ended up being that it was just a couple of these manufacturers that had these apps?
Yeah, so the manufacturer we found is one that like shipped with this installed like as a base feature of their
but then
app.
like other people could install such apps.
Exactly.
And that's
you could install your own app that did basically the same thing.
Right. Okay.
And there may be more than one. So I don't recall actually finding like maybe I just wrote the SQL query wrong, but I don't remember actually finding an app, but I did find a developer. I found an OEM that was doing this, and again, like Google being Google, I was able to like reach out through developer relations, like confirm they were doing this and be like, hey, this is bad. Please don't do this. And this was one of the fun things, was realizing this is not specific to us at all. Like, our app is experiencing this, but these like mobile devices are doing this everywhere.
For all apps. Yep, for sure.
Yeah. And in fact, like, quite possibly, there could be places where like the cell towers get overloaded at 1 second past the hour because a lot of people have this phone. And there was sort of this moment where I was like, Google might be the only place with telemetry that's like high enough resolution that we actually saw that this was happening and had enough detail to put together why it happened. And so we reached out to the phone developer, because we're like honestly, we could be influencing like the total packet drop rate across the internet to go down by a fraction of a percent.
Yeah.
If we get them to fix this bug.
And then did they fix it or
so that developer did respond and said, yes, well, we can adjust the way this works in the next thing. I did not follow up on that, so I don't know if they ever did. And yeah, I didn't find more of them. And at some point, I just got to the point where I was like, okay, that's one developer, but that's just just one needle in the haystack, and there's clearly more of this going on. And so then the next question was like, what can we do to improve on this? And there was a Google exec, I think it's Udi Manber, that would tell these stories sometimes, where it's like, any problem that gets between the user and using Google's services successfully, like, it's our problem. That like, if the user has a bad network connection, that's still our problem. Like, can we make our apps work on bad network connections?
Yeah, for sure.
If the user doesn't know how to spell the thing they're searching for, I know people have been astounded various times through the years at like how badly you can type something, and Google's like, "Did you mean?" and nails it. But, you can put your hands on the wrong spot on the keyboard and type it, and Google can autocorrect it for you. And so that was this philosophy of like, it's our problem. Like, if the users are having trouble, don't blame their phone manufacturer. Don't blame their Wi-Fi network. Like, can we fix it? And so we kind of got to brainstorming about what we could do, and came up with this really peculiar idea. So we see this load spike, and ultimately the reason that creates errors for us, it actually hits us so fast. Like, it's not more load than we can handle. We have a typical like seasonal curve where like daily, there's a high period and a low period, and the peak of that load spike at the low point of the day is lower than like our load at the top point of the day. But the problem is, it happens so fast that the load balancers don't have time to respond. Like, if you slowly ramp up to to 10 million QPS, the load balancers, like, they add tasks, they shift traffic between various data centers. But when it happens, when it's 1 second long, like, none of our infrastructure can even detect that the load spike is happening before the load spike is over. And so basically the problem was, can we smooth this out? Like, if we can just smear this out over a more normal time window, we can handle the load. We just can't respond that quickly. And so we got thinking about ways to smear the load. And the funny idea that we had was, it's only a small percentage of our customers that are creating this load spike. These are the people that, like, we tell them when to call back and they ignore us. But most of the people, when we tell them when to call back, they listen to us. Can we move the traffic from the people that do listen to us to make room? Can we like part the Red Sea and just like put a little divot in our load that their load spike can fit inside of? So that so that they can continue to serve traffic, and like the traffic becomes smooth and flat. And so we have this defensive publication we put on this, on the way we do it. But basically what we did was, instead of just your typical random number generation, typical RNG of just saying, okay, pick any one of the milliseconds in this hour, we like segmented it into buckets, and we're like, okay, we're going to use a weighted random number generator, and like these couple of milliseconds are going to be like, we're going to hand out fewer tickets from that than we do for anything else. And we basically like, we sampled the request rate. The tricky thing was again this clock skew issue of like, the ticket that we hand you is not actually when you're going to come back.
Right.
It's like, you're going to come back, that time plus network lag. So that's where it was really a pain to implement. But we basically just like did this iterative algorithm that's like, okay, here's what we asked for, here's what we got. Let's change what we asked for so that what we get is flat. And so yeah, we created basically load divots that matched our load spikes, and then just like iteratively refine it. Like every hour you recrunch the numbers and redo your random number generator.
And you were, I think you said that the server was telling the client when to call back. So I
Yes.
think that was a nice design feature here, because you could update it pretty easily on the server side. And I think that's interesting because at least in my experience, or at least in probably more basic systems, most people, do client side jitter and they put the jitter
Mm-hmm.
on the client, but the server's not really responsible for telling the client when to call back. And I'm actually curious, was it an intentional decision to have the server tell the client when to call next just to give you more flexibility? Or like, were there other reasons that it was done that way, as opposed to just a client picking a random number or something along those lines?
Yeah, it was absolutely intentional. So that request schedule feature, the whole reason we built it was so that if we had a new idea of a different way that we could orchestrate the requests that would work better for us, that would be, better quality for the client or better load characteristics for us or things like that, that we don't have to push a new version of the APK
Right. Yep.
to change
Makes sense.
behavior.
Yeah.
So giving us server side control to iterate as quickly as we need to on this.
Yeah.
So like once we had everyone adopt the version that had request schedules, we could then push whatever schedule worked for us. And
Yep.
we ended up leveraging that later. Actually, there was a period where it was very hard to get server resources, and we had a feature we wanted to launch that was going to like add a bunch of users. And it's like, well, how do we add users without adding servers? And so what we did was ratchet the request schedule up and down. So like the very old versions of the app, just like hard coded on the client, make a request every 30 minutes, every hour, or something like that. And we ended up tuning that. So again, the battery life issue where they were like, hey, we don't like that you're using so much battery life. And one of the compromises we made was, okay, how about light users of our product, people that aren't actually opening and interacting with this, we dial them way back. They make a request once a day. And the people that are actually opening the app and using it a lot, we crank them up. And it turns out we have a typical like 80-20 Pareto curve
Yeah.
thing.
Yep.
There's a lot fewer people that are heavy users than that are casual users. And so that was a way we were able to like save battery life on the people that don't use the product, save server resources that we're spending doing computation for people that aren't gonna look at the results. And then that's all fully under the server control. And so we had plenty of room to fiddle with the experiments without having to like ship a new APK every time and wait for a billion devices to install it.
Yeah, I mean, it's, again, I'm obviously biased. It's really the entire purpose of our company, but I mean, it's. I think a lot of times people come to mobile and they try to apply like server style methods directly to mobile, right? Whatever. They put the jitter on there, it's like they assume that things can get updated right away. And as we're talking about, I mean, on mobile, A, like things live forever, and B, the updates take forever. I mean, so it's like the more you can do without having to ship new code, obviously the better. So yeah, that is pretty interesting.
I mean, this is what leads to like embedding Lua interpreters into your
Mm-hmm.
client and things like that. Like, can I have some way of shipping soft code to the client because
Right.
you can iterate so much
Yep.
faster? And yeah, personally, like although I worked on the mobile product, I am not a mobile developer and never have been. Like, I'm the server side guy. I'm the server side infra guy. But yeah, like it's because of these like version skew issues and things like that. Yeah, there's a lot of power in like trying to empower your server because your developers are a lot more agile on the server than they
Yeah.
are on the client.
One thing that I've been asking people that I would love to get your take on is, obviously within the industry, we have a really good understanding of server-side observability. We've built up good SRE server type practices over the years. And, to this day, there's nothing like an MRE, like a mobile reliability engineer, right? It's like observability is still relatively immature on the mobile side. And one thing that I'm interested in, and I'd be curious to ask you, since I'm sure Google, if any company was going to think about this, would have thought about that well, is why do you think that's the case? Because these days, I mean, the way that most people interact with these systems is through the app. So it's like, even if you're a server-side reliability person, ultimately, if you want people to enjoy using your services, like you have to make it work well all the way out to the phone. And I guess I think it's interesting that to this day there really still is a bifurcation of you're a server SRE and like I'm not a mobile developer, and I don't mean that in a bad way. It's just kind of the way that people think. And then or you're a mobile developer and maybe you think a little bit about server but not that much. It's still very segmented. And I guess do you think that is good? I mean, do you think that is necessary? Do you think that there's things that we could improve there?
I mean, it's a good question. I think, and like even on on the traditional website, you still have that like front end back end divide. And so I think part of it is that, although like even within mobile, there's also a front end and a back end there. Like there's part of the mobile that's just like, making the pixels render smoothly, smooth scrolling. Like how do I like use the memory well and use the rendering libraries well, to make it display correctly. And then there's just like the back end side of orchestrating my network requests and local storage and local database and caching and a lot of things like that. I mean, yeah, I think it would be really valuable. My dream is that we develop these like useful abstractions that you can just sort of the dream is write once, run anywhere. And for decades now there have been people promising that with various degrees of reliability. Java was one stab at
Sure.
write once, run anywhere, and achieves it to some extent and also fails to some extent. I mean, yeah, the reality is that you develop these like specialties within computer science, then software development for various needs that you have. I mean, yeah, over time, we've got a lot fewer people specializing in, writing machine language than we did 30 years ago. Driver developers, is I think smaller than it was before. Things like USB sort of made a lot of that
Yeah.
more obsolete.
It's more that I think that there aren't that many people in the industry that are actually focusing on like the types of bugs or the types of issues that we were just talking about, right?
Yeah.
Because it's like you then now like you're a quote server side person, but that bug, I think it's an awesome bug because it really is the interaction of pretty complicated mobile specific functionality and the realities of mobile devices and hardware, but also there's a lot of server interaction as well. And I think just in general as an industry, we don't do a great job of like looking holistically across the stack. I would imagine that Google does it better than almost any other company, but like at least in the larger industry, it is pretty rare actually for people to kind of like look at the big picture across those two sides.
Yeah, I mean, I think it's hard. I mean, I think this is one of my superpowers is like finding bugs like this, like finding these really complex like race condition interactions. That's something that I do well and recognize like it's not easy because it requires. I mean, yeah, it's hard to be full stack. It's hard to really understand all the layers between you and the client well enough to diagnose the bug. And like I didn't have to be an expert on client side rendering to figure this out, but I had to have some understanding of like what it's like to be on a client, how the client's network works, and the extent to which we have control over the client's network stack. And I mean, yeah, it is hard to be an expert on more than one thing. And so, I mean, that's why we gravitate towards this. And, that's why a lot of these kind of bugs like just get chalked up to like, yeah, I don't know, we fail requests at the top of the hour. Like, I guess we're just going to live with that.
Well, anyway,
it's hard and expensive to diagnose them.
Thanks for sharing. That is a fantastic bug. I personally love fantastic bugs. In our last little bit, just tell us a bit. You obviously left Google. Now you're at Vercel. Tell us a bit about what you're up to now. Like what excites you in technology currently.
Yeah, I mean, I do still very much love the server space. Vercel is a lot faster moving than Google was because it's a lot younger and able to be more agile. But I love the agility of the server side that you control the machines that it runs on, you know exactly what operating system they are and things like that. And that gives you this ability to just like push code fast. Whereas, both the pre-web days of like, we're shipping this out on CDs and we can't reprint them. And so like, it has to be right. and or even the mobile day of like, we're shipping this APK, and whatever, if it does something bad, we're gonna have to live with the consequences of that for at least an upgrade cycle. Those things I think are difficult. So I like being in the web space. And yeah, I am at Vercel working on the CI/CD team, basically working on making compiles fast, so that you push code, you get a new build deployed as fast as we possibly can manage it. And then also the various reliability guarantees of like, we can detect if your deployment goes bad and help you roll it out safely, help you roll it back when it if it has
Sorry,
issues.
and that's for internal CI/CD or for customer CI/CD?
Yeah, the customer CI/CD.
Got it. Yes. Okay.
Vercel customers, you push code, you want a new website as fast as possible.
Of course. Right.
That's our whole org.
Yeah, cool. Is there a particular part of what you're working on that is giving you the biggest challenge right now? I guess like what are the things that you're trying to improve? I guess like what are the levers that you're pulling currently?
I mean, Vercel is in this classic like scale up startup location where there's a lot of stuff that was just like built to be a proof of concept to see if customers were interested in adopting it, and customers have been adopting it. And so, it's been growing, I mean, high double-digit % year-over-year, growth. And so then, of course, you very quickly hit some of the scaling limits of some of these things where, I mean, like it's an intelligent choice for a startup to make to move quickly and not necessarily like design everything to be absolutely rock solid. The thing I like is I will say, like, rather than building from 0 to 1, I like scaling from 1 to 10. So I like taking a system that like we've proved that the business idea works, and now we just need it to scale. Like we need it to not fall apart. And so I'm doing a lot of work just trying to like get everything to not fall apart from like the duct tape that has built up over time, and just like basically rebuild the entire plane while it's still flying. I think that's a fun and fascinating set of problems.
Yeah, and I have done that at many different points in my career, and there is a particular challenge of keeping things running while you make significant changes. It is a very difficult thing.
I think there's a really fun prioritization challenge, because like, I mean, like any established org, you have a list a mile long of things you hate about your system. Like there's so many things that you wish you could fix. And one of the hardest problems is like, which one are we fixing now? So one of the things that I drive in our organization, I own our technical roadmap, which is distinct from the product roadmap. PM gets to decide what's good for the customer, and I get to decide what's good for the platform. And just decide like, of all the things that I wish I could fix, like I have this many engineer hours to spend. What next? And I mean that's its own fascinating puzzle, because of course you can imagine this perfect system, but it's 25 engineer years to get there. You don't have that. So what's the most impactful decision you can make right now that makes your system better?
Yeah. Cool. Well, before we wrap it up, do you have any tech predictions over the next few years? Obviously, there's lots of things changing right now. I don't know if you're a AI proponent or doomer or somewhere in the middle or any other topic, but tell us where you think things are heading.
I mean, I'm somewhere in the middle. I am braced for the AI bubble to burst at some point, and have been thinking about, I've been looking at like my investment strategies of like, if I really believe it's going to burst, what do I do? Or like thinking of
same
Jensen,
here for what it's worth.
Jensen Huang, like the leader of NVIDIA. I was like, how do you lead the company if you believe you're in a bubble? Like, I know publicly he has to project like, this isn't a bubble, like there's real stuff here, but it's like, I'm sure he knows there's a good chance that like his company could lose 60% of its value and still be extremely valuable.
Yes,
but like,
for sure.
that could happen. How do you even lead a company through that? That's a big question on my mind. But really, like, I view this kind of like the .com bubble, where like there are some bubbles where like there's just nothing of value there. I happen to believe that like the crypto boom was sort of that. Like there's nothing actually interesting in there. But .com, like there were the ridiculous things like pets.com that just bought the buzzword and failed and lost a bunch of investor money. And then you had like Google. You had a bunch of these big companies. So like there were new billionaires that were created by that boom and bust cycle. And so I think AI, like there's clearly some value there. I think there's also clearly a bubble that it's being sort of, overhyped. And so like I expect the bubble to burst, but that doesn't mean that I expect there to be nothing there. And
For
I
sure.
think, there are going to be
Yeah.
some new billionaires that show up, probably trillionaires at this point, from the value that gets created. And so yeah, I'm like neither doom and gloom nor like a big proponent. Like there's value and there's also hype. And at some point, like those two are going to meet each other. The other thing I'm really looking out for, like right now, all these models are just being given away for free because they're in the like market consolidation phase of like, if we give it away for free, we'll get them hooked. And like, what happens when you have to start paying market price for for the electricity that you're using instead of borrowing it from Silicon Valley investors? And so I think there's going to be a great reckoning when that happens. Of like, there's a fair number of things. Sometimes I'll chat with Chat GPT just to like bounce around an idea I have, and I would not pay $20 for that interaction,
Yeah.
but I will steal it for free. And when you start having to pay for that, what things go away and what things really like carry weight. I think that's the interesting problem that we're coming up on.
If someone out there were to ask me to give my opinion on the question that I just asked you, I would probably tell them just to listen to your response, because it's pretty much exactly what I think also. I think the tools are real. I think there are real benefits. I don't think the value is quite as high as the valuations that are happening right now. But who knows? Maybe you and I are wrong, and we'll see. So anyway, gotta wrap it up, but thank you so much. This was a great conversation. That is an absolutely fantastic bug that you shared. I think people are gonna love that story. So thank you for coming on. And that's a wrap for this episode of Beyond the Noise, Signals, Stories, and Spicy Takes. Huge thanks to Jay for joining and sharing a story. You can find this episode and all past ones on the Bitdrift YouTube channel. If you had fun, drop us a review, tell your friends, or yell your favorite hot take into the void. Just make sure to tag us. I'm Matt Klein, and I will see you next time. Thank you, Jay.